Hi, welcome back to the channel. Let's cover the threading macros in Clojure today. A quick story. I actually was guilty not using these threading macros when I started my Clojure journey many years ago. And I was basically happy that I learned the basics of the language. So I started writing my small programs and small web applications. But at some point, my code got a bit messy with a lot of nested function calls. So I eventually had to understand how this threading macros works. And if you're taking Clojure seriously, I think you can start writing your nested function calls first, but yeah, at some point you'll have to understand threading macros. And hopefully this video will help you. So let's take a look into an example first. So we have, let's say, an array of elements, and then we want to start calling some functions on top of that. So let's say we want to increment values first. Let's evaluate that. So we have this. After that, we want to filter, and we want a function that will take our integer, and we want to filter something that's more than 3, for example. We need to move it here. And after that, we want another function call, mapcat fn x, and let's say we want to repeat x times. And if we go here, we insert it here, run again. So we have this array now, and on top of that, we want something like frequencies, right? Yeah. We have this output at the end, but the problem now that this doesn't look good, and it's really hard to follow where we have all these function calls and all that stuff. So we can try to format it somehow, but anyway, it's too nested now, and it's really hard to read this code. But if we take a look what's going here, actually we always have this last argument. For example, this one, then we call this, and we always pass this result of this expression as the last argument to the function call in the upper level. So here we have our threading macro that will help us. So the macro is this, Threadlust. And if we want to rewrite this, we basically now start from this top level argument, and then we want map inc, right? So now we can just put it like that, and this threading macro will rewrite our body here. So it will take this argument and will put it as the last argument in this line, in this function call. So it's similar to doing it like that, right? Cool. Let's execute this. Yeah, we have that. And now we want our filter function, right? Actually, let me keep it here. So we want our filter function, so we can copy it, put it here. But now we already have this bit from these two rows. So we can remove it. And we now can have it on a single line. So it looks like that. Filter. And after that, we want our mapcat. So mapcat fn x. Let's copy it from here. Repeat. Let's execute. So we have this. And at the end, we have our frequencies. Cool. So we have the same result, but it's much easier to read. So we always know that this will put our result of this call as the last argument into the next line. So we can do it. We can read it like we get this. We put it here, and the result of this will go right here. Cool. Makes sense. Also, most editors will support rewriting your nested function calls into a threading macro. So for example, in IntelliJ and Cursive, there is a thread form, which is, this is like a default binding, I believe. But I also have a key for that. So if I put my cursor right here, I can click and execute that command, and it will rewrite my form into a threading macro, like that. And the only thing I need is to actually clean up a bit here if I want those lines, those functions to be on single lines. Yeah, like that. And also I can do it in opposite way. I have the opposite key binding to move it back into nested form. So once again, yep, like that. And I need to add new lines. Cool. So that's why we need threading macros. The other variant of threading macro is a single thread. So the only difference from this one is that the argument will be placed as the first position in the function call. And an example could be something, some map transformation. So if we have like a map A1 and we want to a sock, actually let's start with the nested form. So we want to a sock some value into a map. So we have a map like A1 and we want to put B2. So it will be this. And after that, let's say we want to update the value. We want to update key B and we want to increment the value. So we now have this B3. And at the end, let's say you want to do something like dsock key A, like that. Stupid example, but just to demonstrate the nesting. And to rewrite that into a thread, it will be thread first, because if you notice all this sock update and dsock function expect our map to be placed as the first argument. So we want a thread first, and it will be A1, and then we do sock B2, then we're doing update B inc and dsock A, and we have the same result at the end. So it needs a bit of practice to just get familiar with functions available in Clojure core, and how you write your own functions and where to use ThreadLust and ThreadFirst. But basically, if we have some kind of collection and we want to run functions that transform or filter the collection, those functions are accepting collection or collections at the end of the arg list. So in that case, we use ThreadLust. If we transforming a single object, or our functions are designed in that way that we expect our main argument to be passed at the first argument, we use thread first. The question is what to do if we somehow mix those two. And sometimes there is a pattern like we start basically with this block, but we have this result, let's say, and after that we want to map over that. So if we call map and we do something like key value, right? And let's say we want just to transform it to a string. So we want key and value as a string, and we put a map here, B3. So we have result like that. But the problem now that this map is actually expects this to be the last argument. So we cannot do, we cannot write map here, right? Because this will be placed as this result of these 4 lines will be placed here as the first argument where a function should be. So Usually, the easiest way to do that is to have a let, really. So we do like let, and we call it like whatever makes sense to your program, but in our case it could be something like result, and we get this block, and after that we use Threadlust, and we put our result, and we do map whatever we had here, like that. Yeah, see, same result. And here, if we now work with this result with functions that expect it to be placed as the last argument, we're now switching to the thread last. Also, the other option, which is slightly less readable, I believe, is just to inline it here. So we can put it right here, and it will look like that. It's a bit harder to read because you now need to understand that this entire block represents the first element in this thread last macro, and it's a bit harder to follow. So from my point of view, the best thing is to just place it in a let, and with a bit of practice you will know when you have to split like your threading calls into like intermediate result, so the code is more readable. After that, we have a useful thing called sum, and there are two options: sum first and sum last, right? And the idea is simple. So it basically is same as these two threading macros that we covered already, but it will stop the execution once the argument or result is nil. So let me demonstrate the problem. We have a string, right? A, B, C, and we want to do something like let's create the functions here. So could be nil, and we get a string inside, and let's say if our string is ABC, we explicitly return nil, and opposite case we just return the string. The point I'm trying to do here is to demonstrate a function that potentially can return nil, and we want to chain that in the function calls. So let's say we have the call here. Let's execute that. I need to load the REPL. So this is nil now, right? If we put something else here, that should be our string value, right? But what else we want is to call string capitalize, for example. And this should work. So now we have this capital A here. The problem is that if we call just string capitalize on nil, it will throw an null pointer exception. And if we want our result here, result that could be nil. So for example, we're happy with this result to be nil. Our rest of our program can handle that nil properly. We just want to be safe from null pointer exceptions. So in that case, if we remove this one from here and run that, we will now have this NPE because capitalize got nil from this step. What we can do is to use sum, and it will look something like this. So it will be sum, and in that case, this function call will not be executed because sum will stop here once it got a nil here. So let's return this result. So now we have nil, and if we put something inside, we now have our correct result. One more macro that's available is cond, and again we have this expression, and this is useful. It's much less frequently used as these two from above, but it's useful to know sometimes because it's really good fit for some cases. And let's say we want we have something like step 1 true, step 2 false, step 3 true. So it will basically represent some kind of conditions, and based on these conditions we want or don't want to run a function in the chain in our threading macro. And let's say we have a functions something like step 1 fn, and it will get our con map, and it will just put something like update map steps, and it will do conj step 1. And we basically want the same for all the steps, just to demonstrate. So it will be step 2, step 3, like that. And imagine we have threading macro like that, and we want our steps here with empty vector. And after that, we want to chain our function calls like step 1 fn, step 2 fn, and step 3 fn. Let's execute that. You see the result, all 3 functions were called, and we totally fine to use a threading macro here. But after that, for example, our logic requires that these step functions should be executed only if some condition is true. And it's basically these conditions are just defined as booleans, but that could be a more complex, like even a function call to define if each step should be called. And we can do that with a condition threading macro like that. And now on each line we want to include the condition. So it will be something like step 1, step 2, and step 3 at the end, step 2, and step 3. And now let's execute this once again. So you see now that step 2 was ignored because this step 2 is false. If we change it to true and change, for example, this to false, we'll see a different picture here, like step 1 is now ignored. Final thing I want to talk about is a thing that's actually not used too much, but sometimes it could be kind of useful. So let me demonstrate. So for example, we have a string and we want to like string, say capitalize, string reverse. But after that, we have some function that's like, let's call it bad fn. And it doesn't fit into this chain, but we really want to use it somewhere in the middle of the chain. So let's say we want a prefix and we want our string, and we want to return string of prefix and our string. So it's bad in terms of our usage of that function because it accepts the string as the last argument, and in most cases we using this function, it's the string is passed as the first argument. So, and let's say we want it somewhere here, like bad fn, and obviously this will not work if we want like prefix p, say. This will not work because the result of these 2 lines will be placed right here, and if we run it, it's not what we want. And to fix that, we can use the as thread macro, So it will be as like that, and we call our function something like s here, right? And now, as we have access to this this variable here, we can place it wherever we want. So we can place it at the end, and now we have correct order of our function. So we call it, and we have the correct result now. Let's remove this reverse so we see the better the result. So this string was capitalized, so we see this A, and after that it was prefixed with P and dash. So we have this. But our bad fn is not touched, so we still passing this string as the last argument. While this is useful in these cases, for example, this function is not in our code base, it's from other library, but all our use cases is like that. So it's fine to write it with this helper macro. The other option, which potentially will be better, is to fix the function in our code. So first of all, if this is the function we own and we understand that it's always used in scenarios like that, it's much easier to invest a bit of time and refactor that. So now this string goes as the first argument and just refactor your code base. And that's fine. If you don't have access to that function, third-party library that you don't want to modify, or you cannot modify, you can wrap your function and fix it yourself. So you can do something like fix bad fn, and now we have string and prefix, and we do call here to bad fn prefix string, and now we can use this directly here, right? So it will be p, and we call it again. We call it, and we're getting the correct result. And I think that's it for the video. Hope that that was useful. For more content, please subscribe to the channel, and don't forget to like and comment. Yeah, thanks a lot for your support. See you in the next video. Bye bye.